Thank you. Welcome back, everyone. For those of you in the U.S. who I haven't had the chance to interact with, my name is Jameson, and I'm part of the Vose Ferryfield team here in Ithaca, New York, USA. I hope to be able to connect with you and offer any assistance going forward. Our next session is called From Gut Feeling to Monte Carlo Simulation, presented by Vinueza. Guz is a consultant, trainer, practitioner of quantitative risk analysis, data science, and project management. He has extensive experience helping professionals and organizations understand uncertainty, structure expert judgment, and apply Monte Carlo simulation in practical business and project settings. This session is especially valuable because many decisions still depend heavily on intuition, subjective estimates, or single point assumptions. Goose will show how we can move from gut feeling to a more structured way of thinking about uncertainty. The presentation will introduce the logic of Monte Carlo simulation, expert elicitation, calibration, probabilistic thinking in a practical and accessible way. The goal is to help professionals make better decisions when the future is uncertain. Goose, thank you for joining us. Floor is yours.
Thank you, Jameson, so much, and thanks everybody for staying. I know it's been almost 3 hours now, but I hope this presentation you find it valuable. Yeah, we had a lot of fun when we do it. So thanks everybody for joining. And what we will do before I start, as the pause slide said, and as a way of setting up some expectations for our next steps, I will launch a new poll right now. It's going to be very quick. Right? It's going to be very quick. I'll launch it right now. And at the end of the presentation, I'll launch another one, right? The challenge right now that I have is that I have to do this in approximately 30 minutes. But I think I cut the presentation and I think it's going to be fun. It's going to be fun. So thanks everybody for staying. And while you receive the poll and you answer it, I will start with the presentation. So what I wanted to do, as Jameson well described, is to somehow structure this journey that we have from when we do gut feeling, when you think, you see that, oh my, this should be very long. This task is going to have an impact, an enormous impact on the project, to make it structure and then to run it as a Monte Carlo simulation. So what I will try to do is to generate a small journey that you can all apply in your models. Of course, the model and the presentation will be available for you. So what is the problem with gut feeling, if you could call it the problem, is that it's really good use to generate patterns, right? It's useful to recognize patterns, but often when we're talking about generating times, for example, how long is this task going to take? Is it 10 days? Is it 12? Is it 15 days? Depending on the day, and I imagine that you will recognize that too in yourselves, is that depending on the day that you are, it's going to be optimistic, it's going to be pessimistic, you're going to have an optimism bias, you're going to have proximity bias, right? Because somebody had an issue with that particular, with a related task, so now you think that your task is going to get delayed, etc. So the main idea is to move from here, where we have a gut feeling or something, and to move it right here with some structure judgment, right? So we have some baselines, we have some pillars, foundations, etc. And after that, when we do the structure judgment, generate parameters, then we can transform everything in a Monte Carlo simulation. That's the main idea, right? That's the part of the journey. We're going to go from having some biases to do some structure judgment, and then finally converts this structure uncertainty in a model, like what, of course, Timur showed before and what Graham showed in his presentation, right at the end. What it supports everything at the end is the model, right? And that's the main idea here, right? So we're going to move from a world that we have, you see, one value per output, one non-uncertain output, but it just determines like what's the revenue, 100 million, the cost 80, what's going to be my NPV, where we have ranges and distributions, right? and the revenue is going to be a range, the cost is going to be a range, and derived from that and from the simulation of these two fields, we're going to have a distribution as the end of that, right? And this distribution can be negative, can be positive, or can combine both, something like this. Imagine it's an NPV, and you will have your zero, right? So instead of saying, is this project going to be positive or negative, what you will say, it's what is the probability, right? What's the probability of my NPV being negative, right? So this is what we're going to do. We're going to have this strip, and of course, we're going to bring probabilities into the discussion, and that's what really enriches this discussion. Now, in terms of a roadmap, this is the main roadmap that we're going to use during the presentation. We will start with the business questions, like the NPV, like the what's the total budget, what's the time to work, right? Then after that, after we do these business questions, and you yourselves, I imagine that you will have your own business questions, right? After that, we're going to see the uncertain drivers, and we'll start with this because this is you. This is all of you. You have your own business questions, right? Then we will start with the uncertain drivers. When is uncertainty? Where is it, right? How is it that we're going to process it? I'm going to generate some calibration exercise, so it's going to be to get a little bit interactive. Then we're going to, once we have this, we'll have the parameters of the distribution, right? Then we'll have this, we'll choose a defensible shape for the distribution, kind of what like Graham showed a little bit before, and then we're going to run a Monte Carlo simulation model and create and generate the outputs. And then this is you again, of course, but now making the decision, right? Like this. Like that. So that's the main idea. Now, you see there's somebody with the mic on, so give me just 1 second. Here you go. Now, this is designed for new audiences, right? If you do this already, maybe, and I hope you can learn something from here. Every slide wants to connect to practical model action, and the goal is to make better decisions, and of course, not mathematical decoration. We're not just going to generate mathematical operations just because, but the main idea is to improve and support better decisions. As I said, this is the main roadmap, and this is the one that will guide the presentation. Now, let's go to the intuition. Why is that? Because remember, the business question, you already have it. And where is it that we can find uncertainty? And the uncertainty is located mainly in these 4 different drivers types, right? One is the cost, like unit prices, quantities, productivity, contingency drawdown, etc. If you're more into projects, of course, you will have schedule drivers like durations, permits, rework, etc. And just as a little parenthesis, VoiceOuter has an excellent product called Tamara that helps you with this, right? If you have delays, if you have interactions between tasks, etc., you don't need to mold that in Excel. You can have a Primavera file imported or an MS Project file imported, and you can add uncertainty on top of that. So that's why I mentioned here, right? So you have these schedule drivers, and here you have a solution, something called Tamara, right, which is outstanding. Now, then you have the revenue drivers. The revenue drivers are the demand, production, availability, tariffs, etc. Right? And finally, you have some financial drivers. Financial drivers such as foreign exchange rates, inflation, interest rate, discount factors, etc. Right? So the question that normally we like to ask people, to recommend people to ask, is which variables, if wrong, would change the decision, right? Because sometimes you see that you have variables, and this is something that always happens in our training sessions, that they say, well, yours is 15%, the probability of being negative, and mine is 17. So of course they start to explain this is because of the seed, because maybe you change some of the definitions of the distributions. But the main question is, what is the number that's going to change the decision? Because if I have 17% of my NPV to be negative and you have 15, is this going to change the decision or not? Or maybe if it's 20 and 10 or 25 and 10, you see that everybody has this in their head, in this risk profile that we have in our head, or maybe you already have it in your company, right? But this is where your uncertainty is going to be located. So for each one of these drivers, you will have to generate this journey, right? First of all, the experience, right? This is our SME, right? Our subject matter expert will say, well, this usually takes longer, right? It takes And if you're talking duration, if you're talking cost, it will say maybe this is from 10 to 25 million. Why is that? And then you start talking about it. And then you start talking about the assumptions. Why, when, and under what conditions? Because you see that sometimes people like to talk about the extreme scenarios all the time, but perhaps they don't like to talk about the regular and vice versa. And then we will generate the estimates, the distribution, and the simulation, right? So we just have to acknowledge that we will have to do this for each and every one of the main variables of the model, right? When we do this, right, and then when we are able to select the distribution for each one of the models, right, the best distribution is the one that transparently captures the expert belief and available data. Hopefully we can do that. Now, for doing this, we have these two methodologies. One is going to be the expert elicitation, because maybe you don't have reliable data, or maybe you don't have data. This is a new thing that you're building. This is a new business. And we'll have to have some structured estimates, which is what we're going to do now in a minute, like new technology, unusual procurement, regulatory risk, etc., or data-driven fitting. And we're going to talk about that later. But if you have historical data, and you can use, I don't know, distribution fitting capabilities from model risk, for example. You can use what Graham explained to me in one of the questions, right? How is it that you can generate a very simple cumulative distribution with only a few points, right? Things like that you have if you have the data, right? But you see that everybody says, oh my, we are drowning in data. But if you go maybe to the project management practices, that's not the truth always, right? You have some data. If you are in the financial world, of course you have that. If you are capturing data from, I don't know, websites, applications, etc., of course you're drowning in data. But not every industry has it, so that's why I wanted to make the difference between the two. So now that we have uncertainty, right? Now that we have the uncertainty, what we can do is we can go to the expert elicitation. Now, the expert elicitation, what's going to do is going to convert the experience of somebody into usable inputs, right? And as you always know, every model, right, is only as good as the uncertainty inputs behind it, right? So the main process of the elicitation is going to generate expert judgment, going to be consistent, auditable, and useful. For that, we're going to do some example calibration logic. I remember a few colleagues of mine, my old days, years ago, that we did all this exercise, maybe with different questions, to calibrate what is your profile when you estimate ranges. And we're going to do a little exercise. Of course, I will ask you to do it and share the results here. But the main idea is that I'm going to ask some very, I would say, trivial questions, I'm sorry, and I will get the answers. And the answer is going to, of course, the idea is that for each one of the answers, your confidence interval, I mean, the confidence state is going to be 90%. So if I say how long, for example, how big is a soccer or a football field, right? So if you're very conservative, you can say maybe from, I don't know, 80 to a kilometer, right? You're very conservative because you know 80 meters to a kilometer, because you know that perhaps the football field is like 100 meters long, and you say 80, which is here, or you say a kilometer. Why is that? You say 1 kilometer. Of course, that's totally absurd. Why is that? Because you wanted the right answer to be inside your range, right? But that means that you're very conservative, that your ranges are very wide. So that's your profile for an estimator, right? So what we're going to do, we're going to do this little exercise. And then after that, we're going to use this index. Of course, I'm not going to do all the calculations, but only go through a 10,000 feet methodology. And then, of course, we can share the sheet with you. After that, we're going to do some numbering with a sheet with expert elicitation that's going to have the number that we calculated here, right? So what I'm going to ask you to hopefully all the people that I see that I'm looking at me, right? The main idea is that I will show some questions, like for example this: what is the height of the Eiffel Tower? So please, I mean, don't Google it or don't AI it, right? And maybe you can write it down in a paper, say what's the height of the Eiffel Tower in meters, and you set up a range, maybe a minimum and a maximum, where you are 90% sure, right? Right. So I think that the answers are in, well, here are in meters, so that's one. And I'm going to go through the other ones a little bit faster. And the main idea, I will show you the answers later, and then you will see how many you got right? And maybe you can share if you did the 10, but hopefully you don't Google it and you don't spoil the answers for the others, right? What's the population of Tokyo, right? I'm going to count like 3 or 5, right? Then you see, of course, in million people. In what year was Google founded, right? For those of us, maybe we will remember, right? You remember your first email from Gmail. What's the length of the Amazon River? Right? Of course, if you work in miles, it's going to be a little bit tricky, but I imagine that you can do, of course, the math. What's the current annual inflation rate in Switzerland, right? An approximate one. Of course, if you're in Switzerland, you're going to have the best answer here. Remember, everything is in ranges, right? What's the market cap of Apple? This is an approximate, of course, right? How many countries are members of the United Nations? More than one, I guess. What's the average life expectancy in Japan, right? I'm looking at the chat right now, right? What's the distance from the Earth to the Moon, right? And I think that we're going to have the last one now, right? And what is the global annual production of crude oil? You see the global annual production. I mean, you see that you have the daily one, and then from one country, then you have to sum up more or less, and then in millions of barrels per day, right? So hopefully you got at least 3 to 5, because that's the average that we found, right? Right, and now you can score, and maybe you can share the score, right? The Eiffel Tower, 300 meters, 37 million people in Tokyo, 1998 for Google, 6,000 kilometers in the Amazon River, 2% in Switzerland, 3 trillion, more or less, right? Almost 200 countries in the UN, Japan life expectancy more than 80 years, one of the highest in the world, Earth Moon distance 384,000 kilometers, and the oil production is 100 million barrels per day. So that is more or less right, what I wanted to do. What happens that normally what happens is that if you don't know, for example, how many UN countries, your incentive will be right to make it wider, to make a wider range. And if you know it, if you're in Switzerland, right, or you're in the countries around it in Europe, you will more or less know what happens. Right. So here is the way of calculating that, but of course it's very simple. It's basically the actual hit rate that your basically your range was inside it, and of course we'll have to make some adjustments to it. So this is the basic methodology, right? But it says that it's around 1, you're going to be well calibrated, underconfident. You see that perhaps you go very wide, and maybe if you have less than 0.7, is that you have a strong overconfidence, right? That your ranges are very narrow. So normally, and this is just one portion of the exercise, you will have to do this exercise to see what is your profile for calibration. Why is that? Because you will have to respond to these questions, right? If when the moment that you create an elicitation, or you're being asked for an elicitation, right? Don't ask for a number. You always have to ask for a range. And what happens is that people, the moment that they don't know, you see that they don't know this, they don't do this exercise, they just go here. What is the estimate? And this invites to a single point. And what we will have to do is to go back and always ask for a range. That's what happens, right? So now that we have the methodology, we know that how good estimators we are or not. Of course, we're going to share the recording upon request, as Craig said at the beginning, right? We can ask, right, for this. Now that we know what's our profile in the calibration, we can say, well, what value is practically impossible to go below, the minimum? What value is practically impossible to exceed? This is the maximum. And then what single value feels most typical? From what I've read many times, normally you will ask for this first, then second, then this one is going to be the last one. So you avoid things like, you say, well, what's the most probable value? And you will say, I don't know, 10 days. And then people would say plus minus 3 days, right? To avoid that, I'm sorry, plus minus 3 days. To avoid that, you normally would ask the minimum, the maximum, and then the most probable, right? And then now we have the profile of the people that are going to be showing this. The second step is this, right? Is this expert elicitation sheet that I'm going to show in a minute, right? And what we will do, we'll have to register all the estimators. Imagine that you have 5, 6 estimators that are going to do this, 5, 6 experts, right? That are going to share their knowledge. And then based on experience, you will have to put a weight on each one of them, right? For each one of them, you will have to put a weight. Of course, this is normally something that you don't share that much. It depends, and this is part of the exercise, right? Depending on experience, quality, and calibration. So perhaps you will have, let's say, really well-respected and knowledgeable people. So if it's 100% the total, so each one is going to be 5 times 20%. Everybody's weight is going to be 20%. But if you have somebody that is an expert in, for example, I don't know, damages that could be caused by a dam or damages because of a flood, etc. So perhaps this one is going to be 50 and the others are going to have to prorate. Then you list the questions to be estimated, right? And question by question, right, you perform this estimation like this. I have this small sheet here. Right? For example, this is an impact of a risk, any risk, right? And then I have 3 experts. Expert number 1 generated a minimum 10, 12, and 20 million, 5, 7, and 9, and then 7, 14, and 25 million, right? And what you will do, instead of taking just, sometimes people just take the average of each one of them, right? So what I will do, I will take here, you see that you have a sum of distribution and this linear statistic here. So I will run a simulation here very quickly. And this is going to, and you will see in the graphic down, right? And what's going to happen is that you will see this is the estimation of expert number 1, estimation of expert number 2, and number 3. Normally, the methodology, right, you will say, well, why is it, let's take the extremes, for example, this, and see why is it that you say that the same risk can occur and can have such a small impact versus this one that has a very wide one. Of course, the idea is not to reach a consensus, right? The idea is just to understand why is it, because maybe there's some assumptions that are going to be lost during the process. Then you do that, and then you will reach to number 5, which is this. And it's a very simple calculation here, right? That you will get this per distribution for each one of them. Then you have the weight, you see, for each one of them, and then you have a sum product here. This could be one of them, or you can take the minimum of each one of them too, right? The minimum and the max of the max. So there are different methodologies here for doing the expert elicitation. The one that I like is this one here, where you multiply each one of the weights for the distribution of each one of these. Of course, this is a selection. You can set up this with any type of distribution, but the idea is that you give everybody room to express the elicitation portion of it. So this is a methodology that we follow with some clients years ago, right? And this is a public methodology, like a lot of books about this. It's expert opinion elicitation, it's called. And it generates something like this, right? So this distribution that I have here, right, this is going to be for one question only, right? For one impact. Imagine this is the impact of one risk. So once you have that, you will have to repeat this exercise for each one of them. Normally, the experts, they don't share the results as they are estimating them. So you're not biased, right? And normally what happens is that the most experienced people, of course, is followed by the ones that are not that experienced. So maybe you can do this remote, for example, doing this remote is perfect. But then once you have this estimation, right, once you have and finish this estimation, what's the main deliverable here? The parameters, right? Maybe this is the minimum, this is the most likely maximum because I chose them. Of course, I'm not saying that this should be always the case, but I chose them because of ease of explanation. And now that I have these parameters, what I will have to do is I have to select a distribution, right? It's like choosing a shape that match the reality. And that's the main idea here. And you will have two options to do that. One, right, is to use historical data, as I mentioned before, right? I can fit candidate distributions that are going to now that I know my minimum, most likely, and maximum, and compare with the expert expectations, or use the minimum, most likely, maximum percentiles to build an expert-based distribution, right? And this goes to the main section that we saw at the beginning, because if you don't have historical information, we can build one without having to do a distribution fitting. Once we generate this, right, we can validate the shape of the distribution and log. Basically say, well, this is the distribution for my variable. So you see that one thing is to say, well, let's do minimum, most likely, and maximum as an exercise. But the moment that you're talking about your real project and you have experts that could help you with that, you have ways of doing that, right? And this is a different way and different estimations. If you have data, of course, you can use the distribution fit from model risk. You can take the data. You can see here which one is the distribution that better reflects what you have. Of course, remember that you have the parameters before, right? And the idea is that you can select one of them, one that better fits to the data and the parameters that you have, right? And you can rank it depending on the residuals that you have, and then you can document the final choice and, of course, the rationale. Right? Remember, if the statistical fit contradicts credible operational knowledge or knowledge in general, the conflict will never be ignored. It's documented and you have to decide. But again, the reaching consensus is not the objective here, right? I don't want to put everybody in the same mean, I don't know, standard deviation. The thing is that we will have to decide where are we going, right? Then in the second step, which is track B, you don't have that, right? Then we can set up distributions that are going to be compatible with my parameters, like, for example, a PER or a beta distribution, a triangular, a gamma distribution, a beta distribution, etc. Right? That's the main idea. Once we have that, right, we will do what we call visual validation. And I would say this we'll do in both of them. So maybe this is track A and B. But the questions are normally, right, does the peak feel right here, right? Is the peak where it should be? Is the low or the high tail credible, right? Like this. What happens with my tails? Is the distribution too narrow, remember? Or is it too wide? Right? What's going to happen with that? The P10, P90, P50 match my intent. Remember that before I had my parameters, the ones that I calculated before with my expert elicitation process. So is it okay? And finally, is my reference value inside logical boundaries? You see that you always have what we call a reference value, right? Something like this. You have a distribution like this, and let's say that your reference value is 120. I don't know. This is the 120 USD. 120 USD is the maximum cost of the pieces that I'm manufacturing. If I surpass that one, I'm going to lose money. So I'm going to be in the red here. And normally I will have 5 to 7% probability of surpassing that. That means that, of course, my production is not perfect. But what happens if the distribution that you set up comes here, right, and gives you 25 probability of being over 120? So that means that perhaps I'm overstating my history, right? I'm overestimating the risk, and this risk is not going to be good. So that's why you have to take a look and do this visual validation. I'll always recommend that. So remember, in case you have data, right, you do the distribution fitting. In case you don't have data, you go to the distributions here, select the ones that fits better, and then you do the visual validation. So you have now that, remember, we identify the uncertainty drivers, we generated the calibration, remember, with the questions, and we did the expert elicitations, and we got the parameters. Once we have the parameters, then we go back and say, well, we have the data to fit, so we fit the data there, or we can put the data to an expert elicitation process again and select the distribution. What is the final sequence and results, right? Because now we have done all of the processes that we wanted to do. Now, all of these distributions are going to go to a Monte Carlo simulation model, which is here, right? The Monte Carlo simulation model is going to take each one of the variables that I had, and it's going to include them into the model, right? It's going to be, I don't know, revenue, cost, growth rate, inflation rate, FX, etc. It's going to be all of that here going to the model, and the model is going to look something like this, as we saw before during this summit, right? And the Monte Carlo simulation model is going to give us two things, right? It's going to give us the output distribution. That could be a cumulative distribution like this, or it could be a histogram like the one that I'm showing now, or it could be a cumulative like this, and it will give you sensitivity. Sensitivity analysis is going to give you focus, right? Where should I allocate my resources? Where should I allocate my people, my money, etc. Right? That's the Monte Carlo simulation model. Now, couple of things here, very important. What are the typical mistakes that we should avoid? One, if you have a range in the variables, do not use one optimistic point estimate, right? Move it to ranges. Do not force consensus, as I was telling before. Do not force consensus, but use structural elicitation. Do not choose normal distribution. Normally, I would say do not choose normal distribution as a default, right? Don't ignore the tail behavior, right? Because as I said, you see the reference value. Do not document the assumption. This is something very, very common. I mean, why is that distribution there? And maybe what you will say is that, I don't know, I just received the model from somebody else, right? So document the assumptions and don't treat the sensitivity as a decorative chart, right? These are the 6 mistakes that I would like you to remember to avoid, right? Hopefully that happens, right? And this is going to be the end-to-end workflow. Remember, we will have to map the owners of the variables, generate the profile of the expert, run the elicitation, select the distribution, use the parameter table, integrate into the model, run it, run the sensitivity, and then do the decision making. That's the main idea of this small methodology. And what I wanted to do today, remember, is that we start with the business question, right? Like what's going to be the P80 of my budget, right? How much should I ask the stakeholders or the shareholders to give it to my project so I have 80% of probability that I will finish it on time, hopefully, and on budget, right? And then generate a decision like this. Now that we added the probability on top, what's going to happen is that you can say, instead of saying, yeah, I'm going to do it because the NPV is positive, now you know that your NPV is going to be positive 75% of the time. And then you have another variable to decide. Right? So bringing the probability into the table, that's what it makes it much, much richer, right? So the closing takeaway, right, is that the Monte Carlo simulation is not only about the product predicting the future perfectly. Sometimes we got this question, how do you don't know if it's a simulation of 5,000 or 50,000 scenarios? How you don't know how much I'm going to take, but making uncertainty visible, right? It's like adding, as we were told before, right? Not all models are, some models are useful, right? So add this uncertainty to the model and manage it and discuss about it, right? So hopefully start with a clear decision, right? Structure your expert judgment before the modeling and use the sensitivity to focus attention, right? Right? And always do the best to select the distribution that match the story. I know that this is a journey. Perhaps you're going to use very simple distributions at the beginning, but then maybe after a few months, you're going to be using much more elaborated and sophisticated distributions. So this is what I wanted to talk to you about, right? Hopefully this works where you are, and if you're modeling with Monte Carlo or if you're starting to model with Monte Carlo, more than happy to help you with that, because this is what we do, right? So I'm not sure if I will have questions. Right? I don't think I have any question, right? So if not, what I will do, I will generate a last poll, right? And with that poll, I will hand it to you, I think, James. And thank you, Melissa. Thank you so much. So I'm just loading the poll. So give me 1 second, guys. Here you go. Here you go. So I will do a last one, and I'm going to take it off my presentation, and I will hand it to you. Is it going to be Jameson, I guess?
Oh yeah.
Here
Wait,
you
I
go.
have to answer. I have to answer the poll.
Yeah, please go ahead.
Great.
Here you go. Thanks, everybody.
And thank you very much, Goose. That was a very practical and clear session. I think it is especially useful for professionals who are trying to move from intuition and fixed estimates toward a more structured and probabilistic approach. I did like the connection between expert judgment, calibration, and Monte Carlo simulation, which is very important, and you explained it in a way that is easy to follow and very applicable. Thank you again, Goose. Now, that brings us to the final part of today's summit. We'll now move to a few closing remarks. I'll give those. Anyway, I'd like to thank you everyone for joining us today for the 4th edition of the Quantitative Risk Virtual Summit. We hope the sessions gave you useful ideas, practical insights, and new ways to think about risk, uncertainty, modeling, and decision making. And thank you to all our speakers, Timur Kupiv, Graham Keith, and Guz Vinueza. Each session brought a different and very connected perspective, better tools, better modeling logic, and better ways to structure uncertainty. We also want to thank everyone who joined us live today. As mentioned earlier, the recordings will be available on request, so you will be able to revisit the sessions after the event if you wish. Look out for the email this week.